Hey, you guys who were here last year, what did we do? We went past McDonald's, we went down the road away.
We like parked at some place and then people could...
On the road, here we are. Missouri? Somewhere in Missouri?
Somewhere. You don't know where we're going, but...
We're almost to Chicago, about 130 miles away. Dinner break. Playing Frogger crossing the street. That's them, alright.
Now I'm on TikTok.
Yeah.
You're on candid camera.
Did you take me sleeping?
No, luckily for you. We made it. We're in Chicago.
How about inside out?
Smile.
Yeah, we did.
Good morning.
Good morning.
That's awesome.
From one direction.
Jared Reeves.
Some breakfast, eh?
You do it faster than cars.
I'm off to Argonne Labs. It's only 8:30 in the morning. It's a portion of the labs. Visitor
You may or may
center.
not be able to bring that, you know.
Your students? Okay.
Okay. What time?
And I take it you're staying somewhere close in here?
It's a Fairfield Inn.
This is in the visitor center. This is what I expect to be the boring part of the tour. On the computer is getting the information about energy resources at Argonne Labs. We see a layout of Argonne National Laboratories. See, we're in the lower right corner. That little bitty building. They have all kinds of neat things here.
Right. Black and different doesn't
You still have an Atari? Somewhere here? An Atari?
method to check wells.
So that I can be. He wrote quite a number of programs.
This is Jacob trying to control it.
It's gonna blow up. This system breaks down
Killed everybody.
Hey, you were working? Hold that button. You made it. Well,
Argonne people will watch that they're providing the proton, right? That has the right energy that's going to hit the uranium target.
This is the intense pulse neutron source.
A spallation source for
you know
neutrons.
how frequently it can be pulsed and several times a second?
Accelerator. It's a very old-fashioned accelerator, but it's very reliable. And while it's in its early stages, there are already
Something interesting behind those doors.
And people apply then to come and do research here. You'll see when we go a little further.
We're inside the intense pulse neutron source. This is where the neutrons come and they use them to measure for different experiments. They got SAT equipment here. That red thing is where the neutron goes down, and then there's a detector at the end that does the experiments. We're at the advanced photon source.
I'll take pictures.
Now, the first one finished was in Grenoble, France, funded by the European countries. That has an energy rating of 6 billion electron volts. In 1998, now, as you look at the black chimney over there, the concrete wall, see where it starts? This is where we have our electron gun. All along the line here, we have accelerators, linear accelerators, right here. And then we have a synchrotron. If you look, can you see the berm in the soil with the chimneys above? This is the synchrotron where you're getting higher and higher energies. When you finally get to 7 billion electron volts, it then goes into the big storage ring that's 2/3 of a mile in circumference.
Those are positrons at that point in the storage ring, aren't they?
Actually, we have switched from positrons to electrons.
Okay.
More of a continuous injection instead of pulsing. So it's undergone changes along the line. On these quadruple focusing magnets, can you see how I can focus the beam? Okay, you can try this later after we come back. So I have 3 focusing magnets. This red magnet then is a bending magnet, and you can see that I can bend this over. Again, you could try it. You just have to start it. It goes off automatically. So you can see what all those different magnetic units are doing all around the ring. However, we have almost 1,400 of them. It's amazing that they can get them all working, right? Experimental physics and industrial control systems developed here and with Los Alamos.
Who's up there pretty good? I hope you guys are going to the meeting.
They're talking about some of the instruments that they have here. Now, as you look where I'm pointing, this projection. And all these little buildings that you see are lined with up to 2 inches of lead. If they want to stop the X-ray beam here, they have some instruments here. But the first group is the largest group we have. It's called the interlocking
The silver pipe is where
control,
the
not
beam
linked to one
flows
another.
through.
Now, I cannot answer the question why they say no duct tape. Right, my only theory is that, now you also see that there's chilled water piping. As we look here, you can start to see sample. It's computer
Goniometer.
controlled, and they can rotate it 360 degrees, computer controlled, and get the sequence of scattering patterns with that. But if you had to watch, are efficient, they're non-polluting, from us. Where I didn't talk about the low energy undulator line. That's beyond here. This is a test line. So that I didn't mention.
Here we are after lunch. Everybody's lounging now. Here goes the liquid nitrogen.
The worst thing is that it takes, now, I have 2 pieces of the superconductor here. I've just hollowed out a cavity, which is really not the best, but we'll try it. And I've put a neodymium magnet on here. So, what will happen when this starts to get cold enough is that you will set a current to flowing. All right. And again, it's going to take a while. Here was discovered in 1986 in Switzerland.
A little more liquid nitrogen.
For that Meissner effect. You know what I'm worried about? It's not going through. But this is what I wanted to show you.
This is the Meissner effect.
There. And the neat thing is, if you'll agree not to go in after it, you can all see, oops, we wobbled it a little bit, that this is an ideal thing to create a frictionless bearing. And that's what they're working on. If you remember the video that you saw. Now, if any of you want to try it and feel the repulsion, I'll warm up the magnet for you. Now, when you spin it, it's cold. When you spin it, you have to do it very, very gently. But can you feel the levitation? And actually, you can almost see that it has to be in a certain position. Okay, part of the problem is they just need a little push. Now, realize this is temperature that's warming up, and you can just watch it for a while. When it passes the critical temperature, it's just going to go down. Now, these superconductors somehow have the free electrons so that when they are cooled with the helium, which is 77 Kelvin, they must be cooled below 94 Kelvin. So when that happens, a current starts flowing through there, which creates the magnetic field around it, which repulses the magnet. But now, one thing is that
Here are the white deer.
You know, we don't keep them pinned up.
What if
or
you leaned up
anything.
like right now?
Yeah, you want me to take it right
Yeah. If it's all the time.
Oh, how cute are they?
Okay, let's get it out.
Somebody want to pop out?
Yes.
We see more of Argonne Labs campus.
They say 98 node. I thought it was 128. The one back there they call the Denali Monster. That's the newest supercomputer that's come in here. And
How many processors does it have?
that has 128. This used to say 100. Oh, I see. They have 64 there and 98 here. Wait and get a better picture when we go in. Let me see if I can find someone here.
Look, it's
We're in the
Yeah. they got the
computer
matrix
science
there.
building.
still the computer. It's the matrix over there. Look over there. Maybe that's just
It's the Matrix.
The Matrix did it.
So we ran and stood in this hallway right here. So maybe you know back.
So we're gonna see the cave in a second, but the fourth Friday of the month is FL Demo Day, and we show both these devices off. So I'll just tell you a little about this because it's kind of cool. And since the group's so large, we're gonna have to kind of do the cave thing in a couple steps. So, I'm the administrator. Hey, Justin, what is cave before? These are actually starting to pop up over a lot of places. Now you can see the projector that we're using on this device. It's a theater type projector there. Actually, this is just your standard theater screen. It's very diffuse. Images that come through get blurred. Carolina Krusnira's lab there is building a 6-wall cave. I was in Sweden over the holidays. The university there has a 6-wall cave. So you're going to be wearing these shutter glasses. One special pair has a receiver on it. And this box here is generating electromagnetic field. This is sending it back to the computer. So at all times we can have the X, Y, Z, and pitch, azimuth, and roll of the person wearing these glasses. So they can look up, down, move around. Also backwards. So a couple things. Everybody, the second I'll hold a little virtual hand, we want to make sure everybody's seeing one of those. The other thing is, whoever's wearing the track glasses, everybody's seeing from her perspective. So the closer you are to her, the more true perspective you'll see. If you're standing farther back, things will still look kind of natural, but if you get too far apart, it'll be skewed. All right. And what I'll say something about this. This application was developed by Dave Payne at UIC, at the University of Chicago, and then we're trying to do visualization of that. Much larger than the 10-foot cube that we're standing in. So this kind of gives you some idea that you can build. One of the things I've done is do visualizations of weather systems of like the entire western United States. And you can navigate around the way we are in this space. So I'll drive for a second just to show off some of the fun. All right, so there's butterflies and there's bees.
Yeah, they're hornets.
I'm having a hard time driving. Yeah, it's so now I'm going to hit and they'll continue to come get you. So I'm going to show you how to drive. So simulation itself.
So the data is pre-computed, but our vantage point is real time.
Right. And what we can still do with here is we can pause it and we can drive up into it. Now it becomes much more like a sculpture. We can look at, if we were talking about this, trying to explain to other people, we can say, oh, now you can see the nice bridge here, the spikes that shoot out, and okay. But we can interact with it still. So if you didn't drive the other app, whichever way the little pointer's pointing is the way you're going to go. So if you have it pointed all the way up, push forward, you can go straight up. Okay? Or it'll spin the board around you. Yes, okay, there you go. Does anybody so,
Put a bunch of projectors there on the screen.
why that is. Well, we know. For some odd reason on this machine, you can only log into it once and it's kill X, re-log in. So you can see here, this is a 6-tile display. Seams. You can already see that they're not as sharp as in the big room. Once you get some images up here that are regular in color, and even if they, better yet, if they move anything, this starts to disappear. Oh, here we go. So you see that now it's probably a bad image, but if you don't look up there, if you look down here, you can see that it starts to become difficult to tell. So this is, again, is another high-res display where the application scientists have more access to their data.
That concludes our trip to Argonne Laboratories. Getting in the bus and heading back to the hotel. Here's Chicago. We're going to Navy Pier in Chicago. Taking out. It's a crew, Saturday morning, gonna go see the sights in Chicago. One of the sights in Chicago, fountain. Too bad it's not running. There's a museum of natural science. Over here we have this aquarium and the planetarium. These are the piranha.
Can you see this one too?
This is huge.
But they're little.
This is a nice little painting. Small painting. There's a little one by Andy Warhol. Pablo Picasso, Salvador Dali, Here we have American Gothic by Grant Wood. Ivan Albright. There's another Pablo Picasso. Some by Vincent van Gogh. Monet. Cézanne. Here we are at the Navy Pier Ferris wheel. Going on the Ferris wheel.
Its current was totally reversed and now flows backwards, away from Lincolnshire.
Okay, I'm gonna be really cheesy for a second.
Chicago from the Ferris wheel.
Oh,
It's Navy Pier.
take a good look around you. From the high-rise apartment buildings of the North Shore, West Michigan.
The Navy Pier Ferris wheel. Yes, we were just up there, all the way at the very top. We are in the Crystal Garden. We are in the John Hancock Observatory.
A lot of lights out there.
The Ferris wheel at Navy Pier. Sears Tower.
Going somewhere else.
It's a view from the north side. Strip going all the way up the lake. And out there, airplanes ready to land. Man walking.
Goose Island Brewery is there. Goose Island Brewery is Goose Island. It's on Halstead. It's trying to think where. That's Halstead. Where that's go from there. To the
This tower is big. Hey Jacob, what's up? But,
We made it home. Smile.
I'll be right back, everybody.
After one long ride. Smile, the journey is through.
yes! You can sleep!